Hi guys, today we'll learn how to deploy an IoT application using DevOps Reference Architecture model on multiple clouds. DevOps Reference Architecture abstract layer is composed of two sub-layers, the human factor and the infrastructure. The human factor will rely on the infrastructure services to automate all the aspects or the steps of the application deployment. The logical model of DevOps Reference Architecture is composed of many clouds: the database cloud, repository and continuous integration cloud, monitoring and communication cloud, continuous deployment cloud. The DevOps team will be able to monitor and see throughout the pipeline all the steps of the application deployment and monitor all the logs of the testing, building and deployment. The physical model is composed into 5 sub-modules. Module 1, DevOps team and communication cloud. Module 2, the repository and continuous integration cloud. Module 3, continuous deployment cloud. Module 4, monitoring cloud and the database cloud. User devices will run or use the IoT application to interact with IoT devices. Let's have a look, for instance, at the IoT devices at hand. We have a Raspberry Pi connected to a board, and on this board we have multiple LED lights and a sensor connected, motion sensor connected to a LED light using GPIO. Now, an instance of this physical model is a DevOps pipeline for single cloud. We will extend this DevOps pipeline for single cloud and include 2 other clouds: Google App Engine, AWS Code Deploy, and Heroku. A DevOps team will commence by pushing the code to Bitbucket. Instantly, CodeShip will pull the new version of the code, test and build the application, and deploy it on 3 clouds. All the users of these 3 clouds will be able to interact with the Raspberry Pi by opening an SSH tunnel, secure SSH tunnel, and use the Raspberry Pi commands to interact with the sensors, save the data on the MongoDB Lab cloud. The DevOps team will be able to monitor all the testing and build and deployment logs that will be sent to HipChat. Also will be able to monitor the CodeShip logs and the commit logs from Bitbucket. Now, before we begin, let's also have a look at the code. In this code, we have a SSH tunnel commands or CLI commands that run a few Python script already programmed on the Raspberry Pi. By running, for example, start LED, it will create an SSH tunnel and fire this command, which start the LEDs. And then we can turn off the LEDs using the stop LED. And also we can activate the sensor and monitor its lights, whether it's on and off, for a 5 iteration. We could have created a runnable to use in my IoT servlets to enable the commands to run in the background of the web page. Now, to start, first, let's make some changes. For example, in a README file, DRA version 1 pipeline for multi-cloud deployment. Now, let's save. First, add all the new changes. Then, commit the changes to Bitbucket, DRA version 1.0 for multi-cloud. We push it to the master on Bitbucket. Then let's push the new version. Now, if we go and look at Bitbucket, if we refresh, we received right now a new version of the code, DRA version 1.0 for multi-cloud. Instantly, we notice that CodeShape received or pulled the code from Bitbucket, DRA version 1 for multi-cloud. CodeShape will start the deployment by building and installing the necessary package for Maven app project and for Java. This may take a few minutes. CodeShape has received all the code from Bitbucket. Now it's preparing dependencies, preparing virtual machine, installing Java. Now compiling the Maven project, the sample demo app we created to interact with IoT devices. Now testing automatically the application, which is another feature of CodeShape. Now checking the access of Heroku by exchanging API keys. We notice that building the project, compiling and testing, and exporting the application to Heroku Cloud happens automatically. Same process will be used for AWS and Google App Engine. Now pushing the new version of the app to Heroku. Once successful, we can go and run the application and test it on the IoT devices. Checking the endpoint if the deployment is successful. Deployment is successful. Now we can go and test the application on Maven app Heroku. Meanwhile, we notice that the deployment to AWS has automatically started. If we open the app We received a new version less than a minute ago. Now we open the app. If we click on the play button, it will run the IoT command in the servlet in the background and activate the blinking lights of the LEDs. Let's test it. Notice on the IoT device, the lights start going on and off. We can turn on the lights by clicking on the plus button here. The lights are turned on. Now, meanwhile, at the same time, if you go to Paper Trail will tell us that the lights are on. Now, this is an IoT data. It will be saved automatically to our IoT on MongoDB. Now, a new entry, LED on, is created on MongoDB. Now, if we go back to our application and turn off the lights, on Paper Trail, it tells us that the lights are off. If we go to MongoDB Lab and refresh, a new entry LED are off, data has been created. Now, let's go back to CodeShip. It seems that the deployment on AWS is successful. Now the deployment on Google App Engine has started and the deployment is successful. We received the notification that the deployment is successful. All notification for commit to Bitbucket and the deployment on all the apps are notified to the team using HipChat. Now, for example, if we go to Google App Engine, choose the version that we want and run the application. Now we are running on Google App Platform. Let's do the same process. We send the command for the lights to go on and off, to flicker. And the lights start blinking on the IoT devices. Now we can turn on the lights. Lights are on. Let's go on MongoDB Lab and let's see if a LED on data entry has been created. Here we are, LED on. Let's go back to the application on Google App and turn off the lights. Lights are off on our IoT device. Let's go to the Lab Cloud, see if new entry data has been created. Now, all the deployment logs, testing logs, and the CodeShip build and logs are sent to the HipChat, and all the team members will be able to access those logs. All the team members will have full insight into the DevOps reference architecture pipeline. Thank you very much, and I hope you enjoyed this video.